Hello and welcome back to our numerical data type series. In this video, like we mentioned in our previous video, we are going to be looking at how to work with built-in methods in Python on these numerical data types. So, like we already mentioned in the introductory part of this video, we are going to be working with integers, floats, and complex number. So for these three different data types, I'm going to create three variables that will represent these data types so that we can work with all of them simultaneously. So I'm going to create one for integer. So I'm going to call it int underscore value, and I'm going to assign it to 10. And the next one I'm going to call float underscore value, and I'm going to assign it to 5.5. And the next one I'm going to call it complex underscore value, and I'll assign it to 5 plus 2j. Okay, so now I'm going to also get to the top of this file, and I'm going to import some modules that we are going to be using. So in Python, you can import some pre-written codes. It could be a library, it could be a module, it could be a package. So we are going to get to this part and explain what these things are. But for now, we are just going to import about 2 or 3 modules that we are going to be working with. So the first module we are going to import is the math module. So I'm going to write import math. And the second module we are going to work with is called the random module. So import again random. And the third one that we are going to import is the fraction module. So this time I'm going to write from fractions import fraction. So we are going to be working with these three built-in standard libraries or modules in Python. So now this math module are used to perform basic math operations like square root, powers, sine, cosine, exponential, rounding up or rounding down to the nearest whole number. We can also find the absolute value. We can find the logarithm, and we can use some constant like pi, the e-value, and the rest of them. So a whole lot of that. We can even find the LCM, the highest common factor, and the rest of them. So this random module, we are going to be using it to generate random numbers. Okay, we could generate random integers, random float values, and even we can use it on strings to pick some random items from a list of strings. So, and this fraction, and we know that when you say 5.7, it is usually the outcome of a division, right? So if you want to work with direct fractions, you do not want to work with floats, then you can import these fractions and work with direct fractions like 5 over 2. 5 over 2 is usually equals 2.5, right? So this is usually equals 2.5. So let's just check this. Let's just print this. So we are comparing if 5 over 2 is equals 2.5. So I'm going to comment out the other print statement. I hope I don't have any other print statement in this file right now. Okay, so I'm going to, and it says true. So now this fraction module, what it does for us is that if you do not want to work with 2.5 and you want to work with 5 over 2 directly, it can help you format your figures like that. So now let's start working with them. So from this math module, we have a lot of methods in the math module that can work with integers and can work with floating points. So now the first one we are going to be looking at is the dot square root. So math, you can just write math dot square root, and what do I want to find the square root is this int value, this variable here, int value. So I'm going to change that value to something that has a perfect square. So I'm going to save it, and I'm going to wrap it in a print statement, and let us run that. So now we can see that the square root of 25 here is 5.0, right? So another one we are going to be looking at is assuming we want to work with power. So for now, I'm going to be inserting the values directly on the inside the method, right? So I'm going to, when you say method in Python, another name for method in Python is function. So I'm going to be inserting the numbers directly inside the function. So like what we had here now, we have print the square root of int value, and we know that this int value has a value of 25. So instead of passing this int value here, I could just say find the square root of 25, right? And I'll print, and it's going to give me the exact same value. So I want to be working with the figures directly. So if I want to find the power of to raise a certain number to a certain power, so I'm going to use this power method, and here I'm going to be passing in two values. So the first value is the value that I want to raise to that power, and then the second value is the power that I want to raise it to. So if I raise 2 to power 3, that means that I'm asking Python to perform 2 times 2 multiplied by 2. Okay, I think at least this makes sense in mathematics. So now we are raising 2 to the power of 3. So if I save this now and print, we have 8, right? So but I want this thing to be printing as an integer. I don't want it to be printing as a float. Now it is returning back to me as a float. So I am simply just going to map this as an integer so that it will return just a single value for me. So I want it to come back as an integer. Okay, so we already know what this casting is, so we can now we have that floating point cleared. So now the next one we are going to be looking at is the ceil value. Okay, so this is like the ceiling, and you can relate it to ceiling, right? And what this does is that it takes a floating point, it takes a floating value, and it rounds it up to the highest integer. So for instance, I have this number here, 4.1, and I call this ceil method on it, not minding the fact that 1 is not up to 5, right? But what is going to happen is that it will round it up to the nearest high whole number. So now the next one I'm going to for this one now I'm going to pass in the float value that we have here so that to perform the same method. So now we are working with float, so we can use that float value. So I'm going to save it and run it, and this time around we have 6. So 5.5 have been rounded up to 6. Now, okay, the next one we are going to be looking at is the floor method. So I'm going to type in floor, and I'm going to pass in another floating point. So just like the ceil method was able to round up our figure to the nearest highest whole number, this is going to bring it down to the nearest low whole number. So now we have 4, right? So I'm going to comment this out. Now, another method we are going to be looking at is the trunk method, and what it does is to remove entirely the decimal value, that is the decimal point, right? So now it is going to remove every other value that comes after the decimal point. This time it's not rounding it up, it is just removing it entirely. So assuming I have 9.4.0000 or 4.9000, anything at all, it will just entirely throw away the numbers that came after the decimal value. Another thing that we are going to look at is the uh, FBS, and what is going to give us is the absolute value of whatever we have here. So I'm going to print this. So it says 4. So this is happening because I have the integer here. So now what this actually does is that, so I'm going to delete this so that we have our methods aligned correctly. So what happens here is that this method, ifabs method, will give you the absolute value of whatever value you have here. So for instance, if you have a negative value here, so instead of 4.7 or whatever, we have negative 4.7. So it is going to ignore the negative sign or the positive sign that you placed before your value, and it will give you just the value. So I'm going to run this, and now we have 4 points that, and even if I add a positive value here, it is still going to give me back that. So let's clear all of that. And for the meantime, I'm just going to list all some of the methods that we have worked with. So, and I'm going to add them in a comment. So these are the methods we have worked with so far, and we are going to go on to the next method, which is the factorial. So this method, remember that we are referencing this math before we call all of this method, so that Python goes to the math module and looks for these other methods that we are calling on these values, right? So now this factorial can be used on an integer. If I write in an integer or a whole number value here, what happens is that um, Python will find the factorial of that value. So it's going to multiply every value that is coming up to that value. So what I mean is it's going to start from 1, and it's going to multiply it by 2, then by 3, by 4, and the rest of them. So if you have a basic knowledge of mathematics, you'll understand what factorial means. So I am going to clear this, and I am going to save. So we have that value, and if you multiply all the numbers that precedes 9, and that is from 1 up to 9, if you multiply them with each other, you are going to get this output. So that is it. So I'm going to add factorial to this, and I will move on to the next one. So now the next one we are going to work with is the GCD method, and what it means is that it is going to give you the great common divisor, so the highest number that can divide two numbers. So for instance, I have a number 100 and 200. So this 200, this 100 and 200 can be divided by 2, by 5, by 10, by 20, right? And it can even be divided by 100. So it will go for the highest number that can divide the two of them. So if I save this and run, and now we have 100, because apart from 100, there is no other higher value that can divide the 100 itself and also 200. So it's like you are getting the HCF of two numbers. Now, you can also find the logarithm of a number to a certain base, maybe to base 2, and if you run it, we have 3. Other ones, we can also find the sine of a number, and we can find the cosine, and we can find the tan, just as we can do in normal mathematics. So we can also find the value of pi from this module directly. So you can insert pi in your program. So you see the value of pi is printed for us. And we can also print the value of exponential, and this is the value of exponential. So if you pass in this math dot s exponential and raise it to any power, and what is going to happen is that this value will be raised to the power of 2. So you can run it and see the value. So that is it for math module, and I'm going to continue with the rest of the modules in our next video. So see you in the next video.